Alright, so it says use the graph at the right to find the value of y equals sine theta for each value of theta. Okay, so this is more or less reading graphs, right? So if I say, tell me what y is when theta is 30 degrees, what do you do?
30 degrees. This is 90. It would be here.
Okay, so that's 30, and then what's y?
Like 0.5.
Okay, perfect. Alright, so let's go ahead and like label these. So I can zoom in here and I can label let's go ahead and label it. So you just said this was 30, right? And you said this point on the graph was the point 30 degrees, comma 1/2. Now you said like 1/2, right? So I'm going to go ahead and label this one as 60, and then 90, 120, 150, right? You said it was like 1/2. It is like 1/2. Do you know if it's exactly 1/2?
It should be.
Why is that?
That's pretty much like half of the way up there.
Well, what do you know about sine of 30 degrees, like from triangles? Do you remember how to find sine of 30 degrees from triangles?
From the unit circle?
Or from the unit circle, but like let's think about okay, let's draw our unit circle. Okay, I guess I could have used a better one, but we'll live with this one. Okay, with the arrow pointer, where's 30 degrees on the unit circle? About?
Around, this is 45, that's 60, so 30 would be around here.
Okay, and how do you know then, so we're saying that this point is approximately 30 degrees, right? Okay, so this point right here, how do you know sine and cosine from that point?
The x and y coordinates.
Okay, so what's the x coordinate?
The x coordinate is 1.
Really? I thought
No.
the x coordinate of this one is 1.
No, it's less than 1.
Right. So this point right here, this very first point, is 1, 0. Right? So what does that tell us about trig, this very first point? What angle is this first point?
Either 0 or 180.
So 180 would be all the way over here.
Sorry, 360.
So let's call it 0.
Okay.
Okay, so let's start there. So that tells us what about cosine? Cosine of what angle is what?
Cosine is the x.
So x, in this very first point, x is 1. And what's the angle?
0.
Okay, so cosine of 0 is 1. What's sine of 0?
0?
Why do you say that?
Wait, sine of 0? 1.
Sine of 0 is 1?
No, it's something. Wait, what? I'm confused.
Okay, so my question is, we're looking at this point right here on the unit circle. And this point on the unit circle corresponds to an angle of, I'm going to draw it in pink. Well, it's like an angle of no angle. Right? So it's like 0 degrees.
An angle of no angle.
Right. So the angle here is like no angle.
Okay.
So the question is, what information can we write down using this point on the unit circle and the knowledge that the angle it goes with is 0 degrees and the knowledge that its x-coordinate is 1 and its y-coordinate is 0?
Okay.
So far, what we've done is we've said, okay, that tells us cosine of 0 degrees the angle. So this is, I'm going to write very carefully, I'm going to put degrees here. Okay, this is 0 degrees the angle. Cosine of that is 1. Because this point has x-coordinate 1. Alright?
Okay.
So what do we know about sine of 0 degrees?
Sine of 0 degrees is 1. No.
What is sine?
Sine is the y-coordinate.
Okay. And where is 0 degrees on the unit circle?
0 degrees is like right on the line here.
Right here. Okay. So we're looking for what coordinate of this point? If we're looking for sine.
You're looking for the y-coordinate.
Okay. And what's the y-coordinate of that point?
1.
Be
0.
careful. 0, right? Okay. So that tells us that sine of 0 is 0.
So it's some weird number.
Oh, wait, I messed up. See, look, I wrote degrees here, and that's just wrong.
It's radians.
Because sine of 0 is 0 in the
1.
length sense, right? Because
Just
sine,
the number.
the numbers on sine, sine values come from here, right? The sine values are these blue values that go up and down the y-axis, and I'll keep using pink for the x-axis. The cosine values are these pink values that go back and forth across the x-axis.
Okay.
Okay, so now back to the question in the homework set or whatever.
Something.
It told us to use the graph to find the value of sine of 30 degrees. And we can do that. We can say, okay, there it's 1/2. Right?
Yes.
All right, how do you know that it's actually exactly 1/2?
You could use a calculator.
Okay, you could. But that's not the official understanding way to do it. How do I know that if this angle right here, so this is the kind of thing we've been doing for a while in terms of I want to understand this triangle right here. And I want to know that if the hypotenuse is 1, and that's because we're dealing with the unit circle, and the angle is 30 degrees, why is it that the distance up and down here, the height, why is that height 1/2, geometrically speaking?
Because
Remember how this works? What if I give you a little hint? I'm going to give you a little hint, and I'm going to draw a dotted line over here.
it can flip itself.
And become what?
A translation.
So
that means it would-
this whole triangle now.
the radius of this.
Hold on. So I'm drawing this yellow triangle here.
That really doesn't kind of exist.
Right.
So this radius is 1/2.
No, 1.
1.
1.
This is 1.
That's
1,
also
2.
1.
And since this is an equilateral triangle.
Uh-oh.
Oh, whoops.
Okay, well, you circled it anyway. It's still an equilateral triangle. The thing you circled is an equilateral triangle.
Okay, the thing I circled.
Why, though? Why is it an equilateral triangle?
Because it's an exact duplicate and it's a 30, 60, 90 triangle.
Okay, so
this must be 1.
let's go
So
let's
that's
go
half.
let's go and piece it together step by step.
Okay.
All right? Now this length right here. This is 1 because it's an exact duplicate, like you said. It's also the radius of the circle. Okay? That tells us what about this overall triangle? The fact that this is 1 and this is 1. What does that tell us? What's the word for a triangle that has this thing equal to that thing?
Isosceles.
Right. And if I have an isosceles triangle, then the special aspect of that is that whatever this angle is, this blue angle, and whatever this other blue angle is, they have to be the same. Right? And then we go up here and we say, okay, I duplicated this angle 30 and 30, so this total angle is 60.
Okay.
Which means these have to be 60 because the total has to be 180. Okay? So when you jumped straight to equilateral,
I did.
right? And you have to be careful because the line of reasoning goes through isosceles, right? The last conclusion that I draw, that all three sides are the same, only comes after I know that all three angles are the same.
60.
Okay? And that only comes after I know that it's isosceles, and I know that whatever these are,
This one will have to be.
they're the same.
They're the same.
These are the same, and because this one is 60, why is this one 60? Because I started with a 30. The very beginning of the whole trip through this problem was to say that was 30 degrees.
Okay.
So when I reflect it through a mirror, I get another 30-degree angle.
Okay.
And 30 and 30 is 60. And then we say what two numbers that are the same add up to 120. Okay, now it's 60. So now we can finally say, all right, this is an equilateral triangle, which means this total distance here on the right has no choice. I'll use green now. This distance on the right has no choice but to be 1. Now, you also added another fact when you said that this and this are the same. Okay?
Okay.
That is why we say, okay, I've got two things that are the same. They add up to 1. How could that possibly happen? There's only one way for that to happen, and that's if they're both 1/2.
Okay.
All right? So that is a very careful line of reasoning. Do you understand? Where like, I'm not like, oh, these two are 1, therefore it's equilateral.
Okay.
All right? So, I'm going to pause it now, because this is a long enough video
It's plenty long.
for this one. And we also, the whole time, we didn't even get past number 1. Because this whole time we were talking about sine of 30.
Oh.
Okay? But I'm going to pause the video, and then we're going to do a new video where you're going to go through that whole line of reasoning again.
Okay.
Okay.